Hey everyone, let's do some absolute value equations, Unit 6. The absolute value of a number is the number's distance away from zero. So what that means is if we look at a number line and we take into account, let's call it the absolute value here or let's look at the distance here from 0 to 4. Okay, 0 to 4 is 4 away from 0. That's pretty obvious. I think that should be something that you should know. However, from 0 to negative 4 is also 4 spaces away. It's the distance from 0. Okay, so you move 4 spots to the left or 4 spots to the right. That's what the absolute value is. The absolute value symbol is represented by two vertical lines, looking something like this. The absolute value of 4 is 4, and also the absolute value of negative 4 is also 4. Okay, so you start at 0, and however many numbers or tabs or sets it takes to get to your distance, that's the answer. The absolute value can also never be negative. We'll talk more about that later. Okay, so it's the distance away from 0 is what we're looking for. An absolute value equation represents the two numbers that have the same absolute value. So here, the absolute value of x equals 7. Okay, so therefore, x equals both 7 and negative 7. Remember, the number line would show us equal distances there. The absolute value of 7 would just be 7, but the absolute value of x, if that equaled 7, there'd be two answers. So a lot of our problems going forward are going to have two answers. Here are the steps to solving an absolute value equation, and we're going to do a couple examples after this. We want to isolate the absolute value. Then we want to split the equation into two equations, one with a positive result and one with a negative result. We're going to solve both equations, and then we're going to graph by plotting two dots on the number line. I'm going through this relatively quickly because you can pause, and also it makes more sense to show it with an example. Like this. Example number 1. 2x plus 3 minus 4 equals 11. So, what does isolate mean? Isolate means I want to get everything within these two lines by itself. So, we will add 4 to both sides, leaving us with 2x plus 3, the absolute value of that, equaling 15. Great. We have isolate now. Now we need to split, because everything within this absolute value, okay, inside those two vertical lines can equal one of two things. It can equal positive 15 or negative 15, because they're both going to be equal to 15. The absolute value of 15 and the absolute value of negative 15 both equal 15. So I'm going to put 2x minus 3 equals 15, and 2x minus 3 equals negative 15. Okay. If I add 3 to both sides on both equations, I should get something like 2x equals 18 here, and 2x equals negative 12 here. Divide both sides by 2, and x would equal 9, and x would equal negative 6. Divide by 2. Guess I should show my work. Divide by 2. So x can equal 9 or negative 6 in this equation. If I were to graph that, I would have a dot here on negative 6 and a dot here on 9. Scary in math to have two possible answers, but in this case, both would work with the absolute value. Let's go to another example. Example 2. Negative 2 times 5x plus 6 equals negative 14. We're used to seeing parentheses here, maybe not absolute value, but if they're squished together, anytime in math you have numbers squished together, you want to do your best to multiply them. I want to isolate first. I want to get this 5x absolute value by itself. So I'm going to subtract 6 from both sides. And that should give me negative 2, absolute value of 5x equals negative 20. Now I'm going to divide both sides by negative 2. And that will give me the absolute value of 5x equals 10. Didn't finish that there. The absolute value of 5x equals 10. Now, once again, everything inside that absolute value can equal positive 10 or negative 10. So I need to solve for both situations. 5x equals 10 and 5x equals negative 10. Divide both sides by 5 on both problems. X equals 2, x equals negative 2. And I would show that on my graph by putting a dot on both possible answers. If you were just doing it without a graph, you would probably write something like x equals 2, negative 2, or you could use the word and. Make sure that I see that you know that there's two possible solutions here. Let's go to a third example. Example 3. 3k plus 1, the absolute value of that, plus 9 equals 3. The first thing I need to do is isolate. Once I've isolated, I'm going to subtract 9 here from both sides, and I get the absolute value of 3k plus 1 equals negative 6. Be careful with your absolute value. Make sure it's more extended or different than a 1. You don't want to think it's 3k plus 11. And, oh, we have a negative result over here. But if I remember right, if I go back to my notes from earlier, an absolute value can never be negative. An absolute value can never be negative. Therefore, there's nothing I can put in for k that would allow negative 6 to be the correct answer. The only thing I can write here is no solution. Awesome. All right, head to the try it problem, please, and I will see you in class.